Hi, I'm DJ Ware. On this episode of the CyberGizmo, we're going to be talking about what exactly a virtual machine is, right after this. There we go. Sorry about that. Still working out some of the features here and trying to understand how things work. So I thought, I've done a couple of things about virtual machines, and I thought, well, maybe I better take a step back and for those people that don't understand them, talk a little bit about what they are and what they can do for you. So that's what I wanted to do today. So let's talk about the traditional way of doing things with a server. So I can stand up a physical machine. I can install the operating system on it, the utilities and the libraries and everything I need in order to run whatever particular thing I needed. But in days past, typically only one application was installed on the server, and the reason for that was twofold. First, it made it easier to track down a problem, because you knew that if it was in the web server, you knew that it was probably the server that had the web server running. Or if it was a database problem, you would know it would be on the server that had the database. The other thing it allowed was that it allowed me to create, let's say if I wanted to scale up my web servers to handle additional traffic, I could do load balancing between one or more of them. So there was a lot of reasons for that, but the problem with them, with a single server approach, it was good for its day when servers were single core, didn't have a lot of memory, didn't have a lot of disk, and so having multiple servers was fine. But as the server CPU architecture changed and we started to get multiple CPU sockets on the machines, plus each CPU had multiple cores in them, then it became harder and harder to fully utilize the machine by just running a single app. And in fact, that was really kind of wasted. In order to do that, you would waste all that other hardware that was sitting there and not doing anything. So, yeah, I mean, that was a problem, right? So that was a problem. So yeah, it didn't take advantage of all those the processors, and it didn't take advantage of the amount of memory that those machines were packing too. Some of them today are north of 2 to 5 terabytes. I mean, you could put an awful lot of memory on these boxes today. So the other problem you had is that if I wanted to scale up my server farm using single servers, I had to keep adding another server to the rack. So my racks expanded. My space that I needed to store those racks expanded. The amount of power that my facility was using increased. Also, my cooling costs went up. So, and I was using my hardware inefficiently. I remember that before virtualization came in around 1998, somewhere around in there, for Linux. Now, of course, the virtualization goes way back, and we'll talk about that. But it was a very inefficient way of doing things. And as the cores increased in the year about 2002 or 3, then we started seeing problems, and with the efficiency of the machines, just 30% utilization, 20% utilization, and the managers were just, what can you do about this? So the other problem that we had is that a single server, it was very expensive to do high availability with, because you basically had to replicate the hardware, even though it wasn't being used very efficiently. You had to replicate the hardware for every server that you had. And trying to implement 5 nines, I remember nobody would go that far because it was just way too expensive to do it. 4 nines was more common until we started getting into the virtualization platforms. And the other problem you have when you have a lot of servers is that because of the way that the mean time between failures is calculated, the more servers you have, the more frequently your systems will fail. That's just the nature of the calculation itself, and it's also a matter of statistical truth that the more servers you have, the more chances you have for one of them to die during a business hours and under a crunch. So yeah, virtualization isn't new. Burroughs introduced the B1700 back. I think they first there was the design for this goes way back even into the 60s, but in May of 1972 they released the B1700, which had initially something called the proper language processor. They later the marketing renamed it. I think it was called dynamic multiprocessing. But basically what it did was it laid down a virtual machine for COBOL, it laid down a virtual machine for FORTRAN, and it laid down a virtual machine for SDL, which was their version of ALGOL. So basically that's what you had. It was more like an approach that Java had, so that was kind of the first one. And so it didn't matter how many COBOL programs you had running, they would all run within that same VM. And the same with FORTRAN, the same with SDL. But the idea was to have the environment shape to the needs of the programming language, because FORTRAN has a different word size than COBOL does. They also have different efficiencies with the instruction set between each other. So yeah, it's quite different. And so the virtual machines were designed to try to optimize for that. IBM had their VM370. They introduced that also in 1972. I think that was later. I know Burroughs was first. Burroughs typically was, although IBM usually took the credit for it because they knew what to call it. And the press, whatever IBM called it, they immediately said, oh, that's virtual machines. And so Burroughs didn't use that word, and so they didn't get credited with having a virtual machine. They didn't know what to call it. I remember there was several funny things like the operating system language for the large system was ALGOL, and then they decided to change it to NuPy, and the funny story about that is the reason why that was the name of the language is because every time marketing would ask, hey, have you come up with a name for that language yet? And they would go, no, probably not. And so NuPy became the default language because of that. Anyway, Digital Equipment released VAX VMS and later became Open VMS in 1977. So it's been around a long time. Nothing new. So from a business case or even a home server case, why would you want to use virtualization over pushing everything into a standard server? Well, you get better server hardware utilization for one, and that unless we'll talk about that, but there is an exception to that. So consolidation of physical servers, I can, because I'm not utilizing the servers to their maximum benefit, it allows me to host multiple virtual machines on the same server, and I can then also get some redundancy and failover support, because I could have the exact same VM running on another server, and if something were to happen to the server that my VM was running on, I could easily switch over to the other version of the VM and keep going. So yeah, that's when 5 nines really became possible. Virtual machines can be cloned. That saves time in the setup and also any additional things that you might want to do. But cloning also allows me to move the VMs around in the event that I'm doing hardware maintenance or I'm upgrading a server. So it minimizes the disruption due to those kinds of upgrades. It also provides developers with an isolated environment. They can, within the VM, they can test their system. They can attach it to their own storage servers that they're testing with and never touch the host environment or the production environment. And so they're free to make sure that everything is working without impact to the production servers. Typically, they're usually isolated network-wise. At least you should. If you don't, you probably would have a problem. I know that I have seen problems with data filtering over into the production systems, which in certain cases, that's not always a good thing. It's easier to migrate virtual machines from one place to another physically within the network. So if I need to move a server from, say, New York to LA, I can simply transport the VM across the network to the other servers in the other data center. There are even processes that will take a physical server and basically configure it so that it can be deployed as a VM. So there are some limitations with that as well. But what kinds of virtualization are there? When we talk about virtualization, sometimes we talk about type 1 and type 2, but there's a couple of more kinds. Those are types. This is kinds. They're different. So the first thing is that you'll have, the first is an FV, or full virtualization. That's a hypervisor that has a thin operating system to manage the virtual machines indirectly through the hardware. Now, VMware would argue that, but anyway, we won't get into all that stuff. But let's just, from the purest standpoint on how academia defines it, we'll define it that way, is that you have a hypervisor that manages the hardware directly. It also manages the environment and sets up the virtual machines, starts them up, shuts them down, creates them, destroys them. So you have something in the middle there that does all that work. It's usually very thin, though. So the guest machines run independently of one another. They're not interacting at all with one another unless you program them to do that over the network. But they are not aware of one another, and they just think that they have the hardware all to themselves. So VMware and Microsoft Hyper-V are examples of full virtualization, FV. Typically, an FV also uses a binary translation to intercept the virtualized calls and then translate them into the hardware. So that if I'm calling I/O on a drive, or I'm allocating memory, or I'm allocating a CPU for use, then you use binary translation to do that. So it's a little bit different than some of the other mechanisms. The second kind is paravirtualization, or PV. And that's similar to FE, except the guests are aware of each other. They can see one another. They know that there's other guests running. It is more efficient. Now, VMware would argue that. They'll claim that the FE is more efficient for certain types of operating systems than PV is. But so anyway, I'm going to say it the way academia would say it, and that is there's less overhead to maintain the virtual machines, period. So usually a PV needs to install software into the guest OS. So VirtualBox is a prime example of something like that. Zen is paravirtualized as well. So in order to modify, so that they modify the view into CPU resources and are able to access them in a virtualized environment, VirtIO, for example, and stuff like that. So there is and was OS level virtualization, OSV. That was called out differently up until about a few years ago, I think. But it's really, today, it means the same as paravirtualization. It's kind of lost what its true meaning was. And the idea behind OS virtualization originally was you didn't need a virtualization hypervisor at all. And that's coming back, by the way. The hypervisors that you see inside that surround containers, that is a form of OSV. So, yeah, it's no longer true. It's sad, but, it did really mean something else. But today, it's kind of bundled in with paravirtualization. Hardware-assisted virtualization, HAV, that's a thing that came about, I think, in 2016. No, maybe a little earlier than that, 2006. 2006, yes. 2006, that came around, and AMD was the first to implement it, called AMD V. And then Intel, I think it was either 1 or 2 years later, they came out with VTX. And so basically that is supposed to provide a way so that the system calls go through what they call hypercalls, I think it is, and the hardware implementations are done directly. So it will assist in virtualizing the CPU, virtualizing the memory, virtualizing the disk, and the other I/O structures on the subsystem. So it's supposed to be faster. However, VMware will tell you it isn't. They think that binary translation is faster for operating systems of 32-bit, although 32-bit operating systems are dying. So I don't think that's going to be true much longer. Zen, KVM, they all use HAV. VMware uses it only for 64-bit, so whether they like it or not, the operating system vendors are all pushing them that way. So, yeah, I mean, it is more efficient for the 64-bit. So anyway, I won't beat up on VMware. That's not my intent with this, is to beat up on them. They were first, and everyone else is basically a clone of what they have pioneered for us. So I'm not certainly going to slap them around. They have done an amazing job. So what kind of virtualization type kind is best? Yeah, it depends. Typical consultant answer. I know, it depends. So if all the systems are using the same operating system, then the OSV method would have been the best one, para-virtualization. But if the servers need different operating systems, then FV, PV, or HAV would be the best in those environments. So yeah, OSV, you're still going to find it. It's coming back. I'm telling you, it's coming back. But para-virtualization is starting to replace FV today, because the advantage that FV once had is being supplanted by the hardware assist under para-virtualization. So yeah, HAV does speed up things for 64-bit. So it is usually faster to do things in hardware up to you can make software pretty efficient, but you can't get as efficient as hardware, because it's got to translate to run on it. So now there's a couple of types. So I've talked about this before. So there's type 1, and that is where the hypervisor runs on bare metal. And so ESXi and Xen VMware and Xen are examples of machines that run directly on top of the hardware. Type 2 would be machines like KVM, VirtualBox, VMware Workstation would be a type 2. Vert Manager, of course, would be. Overt would be another one that would be a type 2. But they have an operating system that is installed on the machine first, and then the type 2 hypervisor interacts with the operating system, not with the hardware. The host operating system does all the work as far as interfacing to the hardware. So what are the limitations of virtual machines? When would you not want to use them? Well, if you have an application that requires high computational rates, that is, it wants all the CPUs and it's going to peg them at 100%, you definitely don't want to put that on a virtual machine, because you're sharing that resource with other VMs. And if you have an application that's wanting it all, then it probably ought to be on its own server, and you don't want to create a virtual machine for it. The other problem is that if you exceed the CPU requirements of a virtual box, especially a type 1, you could potentially crash it. You could potentially crash a VM. So it's probably not, it'll take down all the VMs that are running on it too. That's probably not a good thing. I have only seen that happen once, and it wasn't pretty. It was in production, and it wasn't pretty. Anyway, migration, it turned out there was I think it was a camera that was left turned on for 9 hours, and it was all one large image. This thing was just churning in. Anyway, it took it down. Migration is another limitation if you're trying to migrate, say, an ARM physical machine over to an Intel. That's probably not going to work. That could be a problem. The other thing is hardware pass-through is it's better than it used to be. It used to be you had to depend on whether or not first of all, the drivers were compatible to be able to handle that. A lot of GPUs, for example, in pass-through environments don't want to be shared. So if you do pass one through that is like a commercial one for home use and PC gaming use, you can't share that one with other VMs. So once you've sent it across and dedicated it to a VM, you've lost the use of that graphical GPU. Now there are server ones that you can share, and there's up to, I think, I don't know what it is currently, it's been a while, but there was one that was like 32 users could be on it, so simultaneously with no problem. But anyway, and also depends on whether or not the motherboard's been configured properly for to support the PCIe groups that you need in order to be able to support the pass-through. If you get too much, I mean, because you're passing the group. So if you get too high, you get too much stuff in there, you could end up crippling the machine. So, yeah, and I know that was a big problem for a long time. And I think AMD had that problem with Threadripper at the beginning for a while. I think they've worked all that out now with they've kind of split the motherboard manufacturers have finally figured that out. So, in summary, what are some of the advantages to using a virtual machine? Well, you can template them. That is, I can go ahead and I can create a virtual machine with, let's say, Ubuntu 2004 on it, server. I could install all the systems and packages and everything I need to emulate a web server, and then I can turn it off. I can shut it down. I can create a template out of it, and then I can create as many copies of that as I need. So, and that'll be exactly the way I installed it. It'll have all the exact same configuration. So you probably don't want to have fixed IP addresses when you're doing that, but yeah, you can definitely do that. It does support it does provide better support for high availability, simply because you can, in the event of a failure, you can spin up another copy of the VM, so that'd be a cold start. You can also do a hot start, which is just flip the traffic using a load balancer over to a copy of the machine, the virtual machine that's running on a different piece of hardware. But like I said, high computational processes, not a good fit. Good resource management with minimal overhead. That's really what you want. You want to make sure that whatever server you're bringing into a virtual environment, that it's going to play nice. It's not going to hog resources and just keep them tied up. One of the first things, besides the high computational, what comes to mind would be a database. A database will soak the I/O channels. So if you do install a database in a virtual machine, now I've done some testing, it's been years ago, where we found that the databases were usually 35% slower in a virtual machine. However, if you, on those, this would be like Oracle's database product, but if you put those out on a standalone machine, they perform a lot better and a lot happier. They're not gonna take up a lot of CPU resources anyway, unless you've got a ton of stored procedures, but they do soak the I/O channels pretty good. And just like anything else, if you're hogging resources in a virtual environment, that's not good for the other machines that are trying to use the same channel. But anyway, the other thing is it because of the FE, and this is true of FE, it provides full isolation between the applications. Para-virtualization does not, because the applications can see one another. So with that, that's really all I had about that today. I was thinking about doing this and wanted to go back and kind of explain, what virtual machines do. I mean, I know a lot of you guys know what virtual machines are, understand them, but there's probably some people that are coming into the channel that have no clue as to what the advantages of them are. Virtual machines are still a very good solution for a lot of different applications. And I have heard a couple people say, well, we don't need it. We got Docker. We got containers now. We don't need it. Well, that's not true. That's certainly not true. Again, it depends on the application. It depends on the isolation that you need. It also depends on how often that system needs to be upgraded. Like I said, containers aren't really meant to be long-term applications. They're meant to come up, do their thing, and go away. So they're kind of I'm going to do something and then I'm going to disappear. That's kind of the way I look at them. And the upgrade mechanisms for containers are usually not so good. Anyway, that's all I had today. I hope you enjoyed this. If you did, please like and subscribe. And as always, hope to see you all again real soon. And bye for now.